Hi, I'm Phil Smyth and welcome to our little mini-series on bogs or peatlands where we're going to talk about how they form, where they are, what lives in them, what lives on them, and what they're important for in terms of climate change. And why are we doing this? Well, we want to talk about all things sustainable and sustainability. Well, what is sustainability? Well, there are three pillars of sustainability. There is people and equity, there's environment, and there's economy. And you want to be sustainable in that. And it's all about using things in a way that don't mean that the future generations that come after us do without them or have a lower standard of living based on what we've done in the past. We want to look after our planet, look after our people, and look after our economies. And we're going to do that all in the context of peatlands and bogs. And in order to do that, we're going to have to talk to someone who knows what they're talking about. More an expert, if you will, and we're lucky to have one with us here today. Nuala, nice to see you.
Nice to meet you. You're very welcome here to the Bog Nature Centre, home of the Irish Peatlands Conservation Council.
And it just rolls off the tongue. You have that ready to go.
There you go.
Tell us a little bit, what is the IPCC?
Well, we're a national charity. We're established in 1982 and our mission is to conserve a representative sample of Irish peatlands for people today and future generations to enjoy.
But that is perfect. We are talking to the right person. We're in the right place. Why don't you tell us a little bit about, well, what is a bog and why are they so important?
Well, bogs are wetlands. They're 90% water and 10% dead plant material. And today we actually have the stages of bog formation here in the wildlife gardens. So I'd love to show them to you.
Well, let's take a look.
So we've actually two types of peatlands in Ireland. They're known as blanket bog and raised bog. So today we're going to first look at maybe how a raised bog formed. They're 10,000 years old and they started to form at the end of the last ice age.
Oh, sorry, 10,000 years.
They're super old,
Yeah,
they are.
So does it take that long for a bog to form?
Yes, well, raised bogs in particular are 10,000. Blanket bogs are a little bit younger, only 4,000 years old.
Only, yeah.
Only 4,000 years old.
So with this kind of like layer of there's different to like how they form. What's the difference between a raised and a blanket bog?
Well, age is the first thing. And the second thing is how they formed. So raised bogs started to form at the end of the last ice age and they began with this rolling landscape. So the Midlands of Ireland was left with these kind of hills and hollows at the end of the last ice age. With the climate change, the ice melted and this created these shallow lakes in the Midlands of Ireland. So that's the first stage of raised bog formation.
I mean, like it's really convenient and really nice that you've like obviously provided a lake with us today to talk about these hollows and how there's puddles or little lakes form in the middle. Why are lakes important to how bogs form?
Well, bogs are wetlands, so lakes are wetlands. So this is a constructed lake here at the Bog Nature Centre. And with these lakes, naturally over time, lots of plant material colonise these lakes. So if you think of water lilies, they float on the surface. You have emergent plants which grow around the edges, typically bulrushes or common reeds or irises even. And naturally over the time, these plants, they flower, they produce seeds. In autumn time, their leaf litter sinks into the bottom of the lake. And it would take 3,000 years, but these lakes would eventually fill up to create a fen.
So you've got kind of plants and life growing, dying, and layering on top of each other, and then eventually the water leaves to grow, which is left. Is that what a fen is? Is kind of like layers of plants left in a mound?
Yes, but the water never leaves.
Oh.
So remember, a fen is 98% water, 2% dead plant material. So it's simply that the plants fill up the lake. So we don't have this open water habitat anymore. We have a very wet area with a water table at or just below the surface.
And things don't decompose in that. I know I saw on the way over, there's a tree over here that I want to have a look at. We kind of had a look at. Things don't necessarily decompose in it.
No, what's interesting about our water is there's very little oxygen beneath our water. So if you look at a woodland or a grassland or even our gardens that we're in today, beneath our soil, it's a thriving ecosystem. Earthworms, bacteria, fungi, and they all need oxygen to survive just like we do. But they don't have gills like fish. So in a wetland like a lake, they can't survive there. So they are just plant material built up over time, but they've never actually decomposed like the leaves in a woodland would in autumn time or the garden materials we put into our compost bins.
So things can be preserved, and we're going to take a look at something that's been preserved for like a long time right now, yeah?
Yeah, absolutely.
Cool. Oh, awesome. This looks gnarly. How old is this?
This is 4,000 years old.
Sorry, 4,000?
4,000. It's an example of an oak tree that lived in Ireland, along with many other trees 4,000 years ago. Most of the island of Ireland was covered in trees then.
Yeah, question. Obviously, this is 4,000 years old. Looks awesome. How is it still here 4,000 years gone?
Well, we know 10,000 years ago we went through a weather change, a climate change. Our weather got really sunny and warm. Ireland isn't known as that
No,
today.
no, it's not.
So we went through a second climate change. That was 4,000 years ago, and our weather got wet and rainy and windy, typical of the temperate climate we have today. And these trees that were growing in Ireland, they simply fell over where they were standing here in the Midlands of Ireland, and they became buried in the water. They waterlogged, and it goes back to the same thing, that water is lacking in oxygen. So the agents of decay can't survive there.
Okay, so you had like these trees which are kind of like got a little bit wobbly because obviously the ground's unstable, and then they fall over and they kind of form another layer on top of what we like with the plant life that we have, like the lilies and other stuff that's here. I suppose, does that, because there's no agents of decay, there's no kind of the oxygen's locked there, does that create a special environment in terms of the soil, or what conditions are here?
Yes, well, at this stage, 4,000 years ago, remember these lakes would have been in contact with groundwater, so they would have been very alkaline in nature. As the layers of plant material built up, and now we have another layer of this woodland layer on top that's fallen over, we have a change in pH. The pH now is turning more acidic. The plant material is in contact with groundwater, which is alkaline, and indeed, they're now going to be fed by rainwater.
Okay, so that was really nearly acid rain types of obviously that alkaline. So it's really interesting to see. And I know in later episodes we're going to look at kind of like the flora and the fauna, what's in here. But what I'd like to do now is actually I'm going to show actually over there a little experiment that they're only going to need a cabbage to do.
Brilliant.
Maybe. And this is the magical cabbage in question, a red cabbage, even though it's a bit purple. And it is not magical for any possessed reasons, but because it produces something magical, which is this stuff, which is cabbage juice. So you make it in a pot yourself with a little bit of water, and it is quite potent. But what it is a universal indicator, and it universally indicates, i.e. gives you an idea of how acidic or basic a liquid is depending on its color. So I have three liquids here. One is water, which should be about 7 in the middle. One is a kind of a bleach cleaning liquid kind of solution, which should be really basic. And then I have this one here, which is our bog water. So we're going to see what colors come out. So by adding a little bit of this to our bleachy type cleaner, you'll see that the purple liquid turns quite green, which is quite nice. So it's giving an indication of a basic color with green. In the middle, this normal water, tap water, you put it in, same liquid, and you see it gets that kind of purple neutral color, which is kind of similar to what it is already, so somewhere in the middle. Now, when we add this to our bog water, what do we get? Nice. We kind of get a reddy color, which is an indication of it being a acid. You're going to see this color for basic because it's cleaning solution, blue for somewhere in the middle, red for acidic because bog water is acidic, and those special flora, those flowers and plants all live in it because of this acidic atmosphere, is environment that it is. So it's a good test for you to be able to do yourself with something as simple as a cabbage, to take a look at your environment, and you can test other things and see what kind of colors come out. But if you've a bog to go near, this is an experiment that you can try yourself, and it's about getting involved and understanding the science. Even if you understand a little bit of what we talked about today, use it as a jumping off point to go explore other things. And this is about the flora that lives here, but what about the fauna, the animals? We're going to talk about that a little bit in our next episode, and I hope to see you there. Bye.